What I want to do is think a little bit about mom and fetus in terms of oxygen flow and really keep track of the total amount of oxygen that's going from mom over to the fetus. So to do that, let's actually refresh our memories in terms of where the oxygen is flowing from and where it's going to. And remember, the fetus has these two umbilical arteries. These umbilical arteries are coming off of branches from the internal iliac arteries. And these umbilical arteries are actually going through the umbilical cord. So this is our umbilical cord down here. And they start branching. These little arteries start branching. So let's draw some branches here. And let's say this one branches down here. And what they're branching into is this giant plate. We call this the chorionic plate. So this is our chorionic plate. I'll leave a little opening there. And on the other side of the chorionic plate is a pool of blood. So this is a pool of blood that is formed by mom. So mom actually has little arteries that head into this pool. Let's draw a few arteries. And they literally open up into this pool of blood and release their blood. And on the other side, you've got some veins as well. When I say the other side, I mean right here. You've got some veins draining blood away. So unlike most situations where we think of a closed circuit, here you have some veins and some arteries pooling into this place. And on the other side of this is the uterine wall. So this is all these vessels are kind of punching through this wall. But this is a very muscular wall. Remember, this muscular wall is going to be really important during the delivery because mom is going to use this to help push the baby out. So this is our strong muscle here. And we've got some muscle fibers all through here. So this is the structure of the placenta, right? And we've got blood coming into this pool and blood exiting. And on the other side, because there's such rich blood in here, what happens is that this chorionic plate has little extensions that come out and kind of dip into this rich blood. And behind those extensions, or within them, are the vessels. So little capillaries go in there as well. And these little fetal capillaries pick up oxygen. And they come around and they gather and go back into the umbilical stump or the umbilical cord. And all of this oxygenated blood kind of goes into one big vessel. So this is the flow of blood. And down here we have the umbilical vein. Umbilical vein. So that's kind of the route that the blood takes. And on this side, on mom's side, we have uterine arteries and uterine veins. So that's mom's half of this placenta. Now, what I want to do is actually kind of go one by one through each of these vessels and think about how much oxygen is there. So oxygen either comes in a dissolved form, we call that partial pressure of oxygen, or it's going to be bound to hemoglobin. Really just two options, right? And the same two options apply for the fetus. So let me write them out over here. Either bound to hemoglobin or dissolved. And when it's bound to hemoglobin, we call that HbO2. And when it's dissolved, here the units, let me just jot down, are millimeters of mercury. It's millimeters of mercury. So what are the numbers, that are estimated for the dissolved oxygen in the uterine artery? Well, we usually think of arteries as having about 100 millimeters of mercury of oxygen. That's kind of a rough estimate. And for hemoglobin, at this point, about 98% of it is bound to oxygen with this high amount of dissolved oxygen in the blood. In the vein, the number is about 40, and the percent that is bound to hemoglobin is about 75%. So these are kind of the rough numbers, or the estimated numbers, on the maternal or mom side. On the baby side, we actually have much lower numbers. So the umbilical arteries, they have a dissolved oxygen estimated to be about 18. And only about 45% of their hemoglobin, remember they have hemoglobin F, is going to be bound to oxygen. And on the umbilical vein side, it's about 28, so a little bit higher. And about 70% is bound to hemoglobin. So these numbers are what we estimate. Now the question is the amount of oxygen, total amount of oxygen that is lost by mom, is it about the same as the total amount of oxygen gained by the baby? Is the content that is going from mom to baby about equal? Or are we losing some in the system? We would expect that these two should be the same, right? The amount lost by mom should be the same as the amount gained by the fetus. Let's see if that's true. So let me actually show you a little graph that I drew ahead of time. This little graph is based on the same numbers that I just presented, and I'm actually just going to sketch out these numbers. So this x-axis down here is the millimeters of oxygen, or millimeters of mercury for partial pressure of oxygen. And down here we have about 18, and over here we have about 28, let's say. And this is about 40, and over here we have about 100. So these are the numbers on the x-axis in terms of the amount of oxygen dissolved. And on the y-axis we have oxygen content. So it's not really oxygen saturation, it's the total amount of oxygen, including the amount that's dissolved plus the amount that's actually bound to hemoglobin. This first pink line up here, this is the umbilical vein, this pink one down here. And this blue one over here, this light blue one, this is the umbilical artery. Umbilical artery. And so this is all fetus, right? This is fetus. And on the mom's side, this red one on this side, it's hard to see because they look the same at this point. This is the uterine artery. Uterine artery. And on this side, this blue, deep blue one is the uterine vein. Uterine vein. So we have 2 lines for the fetus and 2 lines for mom. And what I wanted to show you is that we have to remember that there's actually 2 lines because of the fact that the umbilical artery has a higher, remember this one has a higher carbon dioxide and a lower pH. And when I say a lower pH, remember that also means higher number of protons. Just keep that in mind. And the uterine vein is kind of the same thing. The uterine vein has a higher amount of CO2 and it has a lower pH and therefore a higher amount of protons. I'll put brackets to indicate concentration. So this is the difference between these 2 lines. Remember we call it the Bohr effect. The Bohr effect is when carbon dioxide and protons make oxygen fall off of hemoglobin or not bind hemoglobin nearly as well. Now a couple things here. You're noticing that the fetal curve is pushed over to the left, and this is because the baby has hemoglobin F, F for fetus. And hemoglobin F is actually much different than what mom has, which is hemoglobin A. And it binds to oxygen, F binds to oxygen more strongly, which is why the entire curve gets pushed over to the left side. Now the other big difference is that these curves for the fetus are much higher than the curves for mom, in the sense that there's more oxygen content overall. And this is because the baby has a higher hematocrit. Remember, the baby actually has, we said maybe 55% hematocrit, and the mom might have something like 35%. So having a much higher hematocrit, what that means is that the baby has more hemoglobin inside of all those red blood cells. And if there's more hemoglobin, remember that's one of the factors that we use in our equation for calculating oxygen content. So this is the reason that the curve is so much higher. Now the main thing I wanted to kind of show you here was that the oxygen that is lost by mom, so going from whatever's in the uterine artery over to whatever's in the uterine vein, that's the total content that's lost. Going from here to here, this is going to be equal to what the baby gains. So what the baby gains on this side is going to be what's in the, let's say, umbilical artery. That's the starting point. The finishing point is what's in the umbilical vein. So this is the increase that the baby has in oxygen. So this is oxygen gained. So you can see that the oxygen lost equals about the oxygen gained, based on my drawing. If I did it correct, that's what it should be. So the gained and the lost do equal one another. Now finally, we have talked about the Bohr effect. And remember, when oxygen is on the umbilical artery curve, it's going to stay on that curve until that moment where it starts losing carbon dioxide. And once you start losing carbon dioxide, you kind of flip from this curve over to this curve. And remember, this vertical distance, we call that vertical distance the Bohr effect. So this Bohr effect is happening inside of the chorion, right? This is the Bohr effect happening on the fetal side. Now on the mom side, inside of that pool of blood, you have a similar effect happening where carbon dioxide levels are slowly rising, and so the oxygenated curve kind of switches over to this other curve where now the carbon dioxide levels are higher, and this is the Bohr effect on the mom side. So on the fetal side and the mom side, you have a Bohr effect happening. And because this is all happening in the placenta, we call this the double Bohr effect. This is one part of it, and this is another part of it. So if you've ever heard the term the double Bohr effect, this is what it's referring to, the idea that you actually have 4 lines, like I've drawn here, happening in the placenta at the same time, and there are 2 Bohr effects that are actually quite distinct from one another.